Good morning. Today I am starting with motion of satellite in a stable orbit. Now as we know that force is equals to mass into acceleration, or F is equals to m into a. This is equation number 1. Now this equation number 1 states that the force acting on a body is equal to the mass of the body multiplied by the resulting acceleration of the body. It means that when a force is acting on a body, then that force is equal to the mass of the body and multiplied by the resulting acceleration of the body. In a stable orbit, there are two main forces acting on a satellite. Whenever satellite is in stable orbit, then two forces are acting on the satellite. These two forces are centrifugal force and centripetal force. Centrifugal force is due to the kinetic energy of the satellite, which flings satellite into higher orbit. It is due to the kinetic energy of the satellite and which flings out satellite into the higher orbit. And the second force is centripetal force. It is due to the gravitational force on the earth, which pulls satellite down towards the earth. This force acting on a satellite due to the gravitational force of the earth, and because of that force satellite pull down toward the earth. Now if these two forces are equal, then the satellite will remain in a stable orbit. Now this is the condition for a satellite to remain in a stable orbit, and that condition is the centrifugal force must be equal to the centripetal force. Now as per shown in the diagram, this is me is the mass of earth and this is your satellite orbit. Here I have drawn a circular orbit and here is a satellite which is revolving in this orbit. Now this me is the mass of earth and this small m is the mass of satellite. Now F in and F out, these two forces acting on this satellite. Now this F in force is due to the gravitational force of satellite, of earth, and F out is due to the centrifugal force and F in is due to the centripetal force. Now this due to this centrifugal force, this satellite will fling into the higher orbit, and due to this centripetal force or a gravitational force, satellite will pull towards the earth. Now the formula for F in is gme into m upon r square, and F out is equals to mv square upon r, where me is mass of earth, small m is the mass of satellite, g is the universal gravitational force, r is the distance of satellite from the center of the earth. F in is gravitational force or centripetal force. F out is the centrifugal force, v is the velocity of satellite, and x is the acceleration. Now the acceleration a due to gravity at a distance r from the center of earth is a is equals to mu upon r square kilometer per second square, where mu is the product of the gravitational constant g and the mass of the earth me, and this product is called as Kepler's constant. These constants are the gravitational force g is 6.672 into 10 to the power minus 11 Newton meter square plus kg square. Mass of the earth is 5.972 into 10 to the power 24 kg, and mu is the Kepler's constant and it is 3.986 into 10 to the power 5 kilometer cube by second square. This is Kepler's constant. Since we know that force is equals to mass into acceleration. Now here the centripetal force acting on the satellite Fin is given by m into mu by r square, where mu is g into me. It is the product of g into me. Therefore, m into g me by r square, where centrifugal acceleration is given by A is equals to v square upon r. Therefore, centrifugal force is F out is equals to m into v square by r. M into A. A is v square by r. Therefore, it is m into v square by r. Now, if the forces on the satellite are balanced, if both the forces are balanced, it means that F in is equals to F out. Here we are substituting F in and F out equations here. F in is m into mu by r square and F out is m into v square by r. Now, from this equation, we'll get the value or equation of velocity. Now, the velocity of satellite in a circular orbit is given by v is equals to mu upon r raised to power half. Here, will get cancelled, 1 r will get cancelled, and v, if we take v on the left hand side, then v square is equals to mu by r, and if we take v, then it is under root of mu by r. Now, if the orbit is circular, the distance travelled by a satellite in one orbit around a planet is 2 pi r. This condition is applicable for the circular orbit, and where r is the radius of the orbit from the satellite to the center of the earth. Now, since distance divided by velocity equals time to travel that distance, therefore, the period of the satellite's orbit t will be 2 pi r upon v. 2 pi r upon v, and v is mu by r raised to power half. Therefore, the time travel, the distance t is equals to 2 pi r raised to power 3 by 2 upon mu raised to power half. This is all about motion of satellite in a stable orbit. Thank you.